So the challenge for the day, Gulfstream. So limited interior space. Nice thing about having the tools laid out like this is I can actually set them in the aisle and I can even step on them since they are bedded in foam. But we're going after something in the electrical panel for a Gulfstream, which is for the right hand side one's tucked right here behind the co-pilot seat. And removing this bulkhead to get access to the front side of this panel so we can get inside and change the component. And being an older, this is a G5 but it's still an older airplane, you got to pull all that out just to get the stupid bulkhead to come out so you can actually get to what you need. And with the bulkhead out, now we can actually get to the fasteners that hold the cover on to the electrical power box to actually get to the component that we need to change inside the box. And so once you get all the little screws removed, you can open the cover, and those are the contactors. But before we go touching anything, we are going to look for voltage and just make sure we don't have any on any of these DC breakers, because I don't want to get zapped and I don't want to let the smoke out of anything. Because as everybody knows, it's really not electrons, it's actually magic smoke that's inside of every electrical component. And when you really mess up, you let the smoke out. And after you've pulled all the main battery contactors, you have to go through and find the emergency power and pull the breakers on them. There's some in the back of the cabin as well. And down here, these run the lights, they run other essential emergency systems, and they pack quite a punch if you let the smoke out of them too. So this is the component we got to change right here, right essential bus DC connector. It causes issues with emergency power not shutting off, the APU not being able to be started, things like that. And this is why I really recommend you get a very thin shaft screwdriver like this, because these connectors that are on it, a really wide tip screwdriver is not going to get in there. In fact, you might even need some of the smaller precision screwdrivers to get to everything that you need to, because your regular old fat bladed 1/4-inch screwdriver is not going to get in there, or it's going to mess them up if you manage to jam it in there. And so once you've pulled the connectors and little Allen screws, this is it. You can actually see through the hole there a little bit of the bus bars that are behind this that are doing the actual connections. This right here is that right there under the plastic, there's going to be a coil inside of there, and literally I don't know what goes on these sides here. It might be some logic or who knows what exactly to have this many connectors or this many control circuits apparently. But what you have going on is inside of here is a piece of metal that is magnetic, and around it is a coil, and when you make the circuit close, that makes the electromagnetic field throw the piece of metal in the middle that gets affected by the magnetic coil. There's going to be two contacts that come down and hit contacts that are connected to these bus bars. I know years ago, I've only ever seen this like twice in my career, but the thing you have to remember is every time one of these closes, and especially every time one of these opens, a little spark of metal, a little spark transfers. With every little spark, a tiny little bit of metal goes. Often carbon builds up in there as well from stuff in the air or whatever that is arcing and getting burned on there. And what can happen is these will still close, but because of the carbon or the shape of the points not hitting perfectly, no current will flow. I literally had an aircraft where we turned this generator on and we could hear the generator lugging the engine down. Like, you knew it was trying to generate, it was doing its job, and yet no voltage would flow. They could hear the relay, we could hear it, like, and finally just going from point to point along the bus bars and wires of the system, I found that there was a generator contactor where you had 28 volts here and nothing there. And that was with it opening and closing. Now, I actually took that one apart. I don't know. Yeah, I could actually take this one apart. It might be fun if I don't have to send it back to find out. I took that one apart, and sure enough, it was carbon built up on the contacts. I actually took some sandpaper, cleaned the contacts, put it back in, and it worked. Unfortunately, this is where, as an aircraft mechanic, you always have to remember that unless you have a maintenance manual procedure telling you how to do something, and this was for a 135 operation, you don't have a clear path to RTS, return to service. So therefore, I had to wait for them to courier another one in and install it, and everything was good, even though the one I had fixed was there. Now in GA, yeah, you can do a lot of things like that and get away with it, because the sign-offs aren't so critical, but anything that is in transport, especially people, this was luckily packages, but especially people, you get into 135s and 121s, the paperwork gets much more serious, and you just taking something apart, figuring out, oh, I just need to clean up the contacts and put it back together and it works, is not what is actually airworthy. Airworthiness is always about the paperwork. It's not so much about the safety of flight or even function. And in that case, I could not have made it airworthy because I did not have supporting documentation to make it airworthy. And that's what airworthiness is always about. So now I'll put the new one of these in and we'll test it out. And now, because I don't know if there might be circuit cards inside of these little microprocessors, who knows? I'm not 100% sure what's in there. They don't tell me. I am going to use the ESD wrist strap and just find a convenient piece of metal to connect it onto. And then that way, I know for sure that I am not going to fry anything inside the component of the new one that I'm about to install right there. Now, quite often, if they are actually something that you'd have to worry about ESD, those red caps could indicate it, but quite often a component that will come in a bag that is actually says ESD. It's types of plastic that help, I guess, dissipate electric charges instead of build them up. I don't know the chemistry or whatever, but I know that they will say stuff. Sometimes caps will say it. It could be a Mylar foil type of bag. Often it's a pink type of plastic is another one you'll see for the bag. Just be aware of it and think of it anytime you're inside of something with a lot of electrical, and who knows what kind of circuits might be in there as far as printed circuit cards, and especially if you're getting into this kind of a rack with all of these avionics boxes. And this right here is why you definitely want to check, as the manual says, and make sure there is no power, because when you see a big fat bus bar like that, or like the ones that were behind this, those carry some serious voltage, probably some serious amperage. You're going to do some massive arc welding, probably really damage some things badly, costing a lot of money, taking the aircraft out of service, and potentially burning yourself or worse. So when there is a caution, pay attention. Gonna get up here. That wind's howling. And plug the batteries in. Which had to be disconnected to go inside that box in the first place. Oh, word. sometimes they just fight. But it's amazing what you can do with both hands. Taking apart this relay assembly, get this cap, got a couple screws holding it. And right inside of there you can see there's our bus bar. And I'm trying to figure out exactly how this works, or how, oh, there we go. Interesting. Okay. So, the actual part that breaks the contact, so I can show it here, is this right here. And then this is spring loaded down, and this, kind of see arcing right there and right there. This has been failing. Now why? I don't know exactly. But at some point when you start to see an arc like that, you get carbon, and carbon actually interrupts the flow of electricity, so that everything going on in here, even if it's working correctly and opening and magnetic field is opening and closing, your contacts will no longer conduct electricity. So we can get that off and get a better look at what's underneath. So there, it's one side of it, and you can just see a couple points here where there was arcing going on. Arcing, it's interesting, now this thing suddenly released when it was locked down before. Alright. Oh, because this actually is keeping it down. That is a very interesting circuit. I wonder. But now you can actually see what goes on inside of here. Like this was actually. I'm not sure. No, that should have been free. This was actually welded shut from the look of it. And I think I don't know. But you can see here there's this part at the top that's opening and closing, and there's a screw, and it's hitting. So there's something electrically going on there that's limiting this. So there's circuits that were notified when this was open, and there are other circuits when this was closed, and you can see the way the points would open and close right there. And apparently one of these, I'm guessing one of these side slide assemblies here was bound, and when I started monkeying with this, all of a sudden it freed up again, because when I first took this cover off, that was stuck down and I could not get it to come up. Something freed up inside of here, but you can see this is its natural position. And then electrically there's a coil inside of here, which you can kind of see the metal thing. I'm not going to open that up, it's probably far enough to get to the coil, but there is a coil, and when that coil is energized, this is held shut electromagnetically, and then the heavy current load going through these two bus bars right here could conduct. And then when you shut it off, the coil, which is powered through one of these two right here, would release, and this would spring up. And for whatever reason, what had happened is this was just down all the time, and the aircraft knew it was down and would not put power on the circuit, even though it should have been going. It had something else it was not allowing, because it knew something was wrong, and it was always shut. And it has protection in the circuit to make sure that it always being shut doesn't start a fire, most likely. The way the logic on this would work, these are slide switch assemblies. Basically, on an electrical diagram, it would be a two-position multi-pole switch, because each of these is connecting or breaking a path when it's up and when it's down. Same thing going on this side. And the logic that the engineers used when they designed this
is, you know, each of these is probably going to different pins, and I'm sure I could pin it all out and whatever if I had a schematic and really cared. And the whole point of it being, though, is to sense if it is electrically locked shut, and so that you just have a closed path. Because let's say if the generator, you know, you need a way to break the circuit as protection, because if you have a short to ground on a generator circuit where the generator can put out some heavy amperage, which jet engine generators can do that, you will very quickly get an overheat and then a fire, and the magic pixies will all come out and create magic smoke. If you don't have a way for this circuit to break. And so Gulfstream designed it so that it could sense that this was locked shut, and it would not provide power in the first place to excite the generator to get power on the circuit. And it would also, by sensing the position of this being in the wrong position to turn on, it was protecting the aircraft. It was doing its job.